Okay, ma'am, you start.
Please, sir. Good afternoon, everyone, and welcome to our guest lecture. First of all, I would like to call our director, sir, to address our gathering and enlighten us with their valuable words. Director, sir.
Thank you, Shilpi ma'am. Today the topic for the guest lecture is medical image analysis and classifications using deep learning. Dear participants, image processing is a very prominent field in the computer science, and this is widely and extensively used by the industry. For example, space industry, agriculture, image processing in medical sciences, robotic visions, pattern recognitions. No doubt, image processing is extensively utilized by the industries nowadays. And when we combine this image processing with the artificial intelligence and especially with deep learning, no doubt the potential of the topic is raised exponentially, no doubt. And today we are fortunate enough to listen Dr. Manoj Divakar sir, who is kind enough to accept our invitation in very short notice. And my suggestion to the students is to learn or to listen carefully and to learn the various tips which Dr. Saab suggests us and discuss about the topic. Now I formally welcome our guest, uh, Professor Manoj Divakar sir, who had accepted our invitations, no doubt, in very short notice on the behalf of MIT School of Engineering and Technology and MIT University Patna. I formally welcome Dr. Divakar sir. Over to you, Divakar sir.
Thank you so much. Thank you so much, director, sir. Now I would like to introduce our guest speaker, Dr. Manoj Divakar, sir. It's my pleasure to introduce our guest speaker, Dr. Manoj Divakar, who has graciously accepted our invitation to join us today. Dr. Manoj Divakar is currently working as an associate professor in the Department of Computer Science and Engineering at Graphic Era Deemed to be University, Dehradun. With 12 years of industrial and academic experience, he is committed and dedicated to the continuous upliftment of the research environment in his field of expertise. With a strong academic background, he has a multifaceted educational qualification. Prior to joining Graphic Era University, he has associated with DIT University, Dehradun, MIT University, Rajasthan. He has achieved his BTech degree from Dr. RML Awadh University, Faizabad, and MTech from MITS Gwalior, India. He achieved his PhD degree from the Department of Computer Science, Baba Saheb Bhimrao Ambedkar University, Lucknow. Dr. Divakar is also serving as professional member of IEEE and life member of International Association of Engineers. His research interests include image processing, information security, and medical imaging. He has published around 110 research papers in peer-reviewed journals, conferences, book and books chapters with national and international publishers of repute. He serves as a reviewer of many international journals like IEEE Transactions, Elsevier, etc. He has also served as guest editors and associate editors of many reputed journals. He also organized many international conferences like Springer, IEEE, and many more. So today we are privileged to have Dr. Manoj Divakar with us to hear their insights and experiences. The topic of our event today is, our topic of our guest lecture today is medical image analysis and classification using deep learning. And I'm confident that sir will provide valuable perspectives and insights on this important topic. Over to you, sir. Platform is yours.
Yeah, thank you. Thank you very much. First of all, definitely I want to thank you, Director Sir, Shilpi ma'am, and to give me the opportunity to be with you as a guest lecture. Definitely, we have to start directly.
Yes, yes, sir. Kindly share your PPT, sir.
Yeah, it is visible.
Yes, sir. Is it? Yes, sir. It's visible, sir.
Okay.
Yes.
So as the topic is, I choose my topic, medical image analysis and classification using deep learning. Okay, so first of all, we have to understand, and definitely you all know, what is the importance of medical imaging. So as if we are talking about the COVID era, yeah. So in COVID era, we know so many things are our life, our daily routine things, and all are dependent on the medical things. Daily, we have to saw many kind of things in news channels that many things are going on during the COVID. Daily, we have new challenges, new kind of doctors also are taking challenges in terms of medical things because they don't have such things, such facilities, so that they can take care about the COVID. So the main thing is that doctor is only rely on the medical images, because through the medical images the doctors can suggest the things that if we are talking about the COVID or any other disease. So all disease, all any kind of disease, definitely doctors are depending on the medical images. So we know the importance of the medical images. So how these medical images are basically generated, that thing we have to understand as a computer science students, computer science researcher, because if we don't know the things behind the medical images, how these medical images, if we know how these medical images are going to generate it, so we can resolve the solution of the problems. So there are two things basically that we must know how medical images are generated. That is the first thing which I am going to uh, continue in my lecture. And second thing, what are the challenges behind after image generation? So that as a computer science researcher and a student, we can sort out that kind of problems. So there are three things which I am going to mention here in my lecture. That is the generation of the medical images. Actually, the correct word is reconstruction. So medical images are basically reconstructed. So how these medical images are reconstructed, so that thing I am going to discuss here, as well as we also saw some challenges that after generation of that medical images, how what are the different problems may occur in medical images. And lastly, we are going to cover the thing that how these challenges, these problems can be sorted out for the purpose of disease prediction and further any kind of applications. Okay, so we are going to continue. So first thing, we don't have only one medical image. We have different type of medical images. So if I'm talking about the medical images are essential component of modern healthcare. Today we have to require medical images. Okay. And if we are talking about the types of medical images, one of the major type is computed tomography, CT images. Basically, we are saying that images are CT scan images. So you must understand that CT scan images are known as computed tomography medical images. Okay, so generally doctor said that you have to go for CT scan images. Okay, some doctors suggest that you have to go for you have to go for CT scan images or you have to go for the MRI images. Okay, so exactly the basic funda behind the medical images is that if doctors actually know about the things, technical things, that what kind of problem you have exactly. So let's suppose if you have some kind of problem in your body, and that is on hard tissues. Okay, inside the human body there are tissues, and generally that tissues are soft tissues and hard tissues. So if the tissues are hard, like bone, okay, so bone, that kind of information, if we need that kind of information in medical images, okay, where hard tissues information, we have to focus on hard, hard tissues. So that time doctors generally suggest that you have to go for CT scan imaging. Okay, and let's suppose some kind of things are happening like in soft tissues. Okay, some kind of tumor is there where like brain tumor. Okay, so that kind of things are basically comes in the form of soft tissues in our human body. So at that time, doctors generally suggest MRI images. So exactly what is the reason behind that? Because the reason is methodology. The methodology which we are going to, the methodology of reconstruction exactly. Okay, the images are basically generated with the concept, with the algorithm, with the mechanism. So here I am going to discuss a mechanism of CT scan images so that you can better understand how these CT scan images are basically generated. So in my first slide, we have to understand about the computed tomography. So computed tomography, CT, it is a medical imaging tool for producing 2D images, for 2D images as well as 3D images to examine human body organs by X-rays. So there are important thing is X-rays. So exactly in computed tomography, it is basically useful to produce 2D or 3D images. Okay, but with the help of X-rays. Okay, and the purpose is definitely to examine the human body. Through these CT images, the internal structure of an object such as dimension, shape, internal defects, density can be easily analyzed. Okay, like you can see in figure 1. Okay, in figure 1, what we have to understand exactly. So this is the exactly showing the process of uh, CT reconstruction. Exactly what happened here. In one side, as you, if you saw CT scan machines, definitely there is a one CT scan machine where we have to lay down on that machine, and definitely through the they from different directions, from n number of directions, the X-rays are basically transmitted. So that concept is I'm going to explain here that what happened exactly inside that machine. So one side there is a X-ray source. Okay, through that X-rays are going to be transmitted, and other side just opposite. Okay, you can say one over the 180-degree angle uh, of the X-ray source. There is other side. There is a detectors. Okay, and that detectors are basically useful to collect the data. Okay, one side there is a X-ray source which are basically useful to transmit X-rays. Other side there is detectors which are basically to collect the data. In between X-ray source and detectors, there we can put the object or human body. Okay, which we have to examine. So what happened exactly? So through the X-ray source, X-rays are going to transmit it. Then these X-rays are going to uh, going to touch human body, or we can say it is moving inside the human body. So what happened exactly is the important point is that as X-rays are moving inside the human body, electromagnetic radiations are going to be generated. Okay, now this keyword definitely you may know that electromagnetic radiation. Okay, electromagnetic radiation is very harmful for the human body. Okay, so there are two important things. Okay, why I am going to stress over this point? Because when we are going to go for CT scanning, CT scan images, so that are not mm, that are not so fruitful for each and every case. Okay, because uh, when we are going to for CT scan images, there are X-ray source. From the X-ray source, X-rays are going to transmit it inside the human body, and as X-rays are moving inside the human body, electromagnetic radiations are going to generate it, and that electromagnetic radiations are very harmful. It is that I read from the research papers from, and this research is basically done by the US, and it is very well things. And if you know the COVID time, one time what happened, that many doctors come on the news channels and they have to say that please don't go for CT scan unnecessarily, because doctors know that if we are going to going for CT scan unnecessarily, that X-rays unnecessary, which is not required, that is going to move inside your human body, and definitely electromagnetic radiations may generate it. Okay, and what will be the effect exactly? If these electromagnetic radiations are large, then cancer cells may develop. So that is very a crucial thing, that unnecessarily it is suggested by the doctor that don't go for CT scan unnecessarily. When it is required, then only you have to. Okay, so that thing. So here, as a computer science, as a engineer, as a student, we have to understand the things, that we have to make some kind of algorithm, some kind of mechanism, some kind of software, so that these electromagnetic radiations should be reduced, as well as CT scan images should be produced. Okay, so what happened after that? From the X-ray source, X-rays are going to transmit it. Human body, as it is moving inside the human body, electromagnetic radiations are generated. And other side, there is a detector. So detector will collect the raw data, which comes through the X-ray source. Okay. Now, these data are collected by the detectors from one direction. Similarly, we have to collect the data from n number of directions. Okay, and all data is going to be transferred to the computer machine, and inside now, as a computer science student, as a computer science researcher, our task comes inside when the data comes inside the computer machine. Okay, so now raw data is going to be collected. Okay, this raw data is going to be processed by the computer science persons. Now, what is our responsibility? We have to collect all the data. We have to process that data, missing data, and as well as we have to perform some algorithms, because that is only raw data. It is not an image. So now it is our responsibility that we have to convert that raw data into the image. Now, inside this computer machine, we have some number of algorithms, different algorithms, different scientists develop so many algorithms. One of the basic algorithm, I'm just putting here name, Redan transform. It is Redan, R-A-D-O-N, Redan transform. So Redan transform is exactly utilized. I can put here, that is Redan transform. Okay. So that this Redan transform is the main transform which is responsible to create the CT scan images. Okay. Now, exactly what Redan transform will do? Redan transform take the all data, raw data, and over that they have their own mathematical equations. They applied that mathematical equations over that data, and some information comes, and that outcome basically known as sinogram. Okay, So that over that data, when we are going to apply radon transform, then one result come with that result is known as sinogram. Okay, so sinogram, SINO, sinogram, GRAM, sinogram. So what happened exactly? That sinogram is exactly not a medical image. Over that sinogram, we have to perform one another algorithm that is known as inverse radon transform. So that radon, now we are going to apply inverse radon transform. So over this inverse radon transform, when we apply inverse radon transform, then we can get CT scan images. Below figure, okay, you can see this is what this is. These are the CT scan images. Okay, so after applying radon transform, we can receive sinogram. Over this sinogram, when we apply inverse radon transform, then we can get the CT scan images. Okay, so this is the whole process to produce the CT scan images. Now, whatever we receive CT scan images initially, so initially that CT scan images may have many number of problems. Okay, what problems may have exactly? The problems can be, there are many problems. Like one of the basic problem is noise. You can see here, this is noise in CT images. Okay, so you can see noise in CT images. It means actually we have visual noises in CT scan images. So you can see like this one image, second one, this image, it is a pure clean image. Okay, but when we add some noise, this is the noise content, noise component exactly. So when this noise component is going to add this image, so the output comes as a noise image. First one is noisy image. So when CT reconstruction is performed initially, the images may noisy. Okay, that is one problem. So when images are noisy, definitely the doctors are not so capable to analyze the thing, to diagnose the things accurately. Okay, so as a student, as a researcher, our first challenge is that if we can remove the noise from the noisy images, because we don't know what type of noise is this, we don't know how much noise is there, we don't know, what will be the impact on the structures, organs which are showing in the medical images. So are they completely visible or not? So noise may affect the things on the medical images. Okay, so this is one of the big challenge. So as a software engineer, as a student, you have a problem exactly that medical images have noise. So first of all, you have to understand what type of noise is this. So you can learn the literatures, because I am talking here about the CT scan image, only CT scan image. Other than this, we have MRI images. Other than this, we have ultrasound images, SPECT images. There are many more. Okay, and each and every medical images have their different type of noise. Okay, so like if I am talking about the CT scan images, in CT scan images, there is one category of noise is poison noise, Gaussian noise. So in CT scan images, generally poison noise and Gaussian noise are available. It comes from the literature. Many researchers find out the things. Many researchers did many experiments. So after getting the experimental results, they can conclude that in CT scan images, Gaussian noise and poison noise generally occurred. Okay, but in MRI noise, in MRI images, the noise is different. There is exactly Gaussian noise. Similarly, we have many other noises in different images, like ultrasound. If we are talking about the ultrasound images, the noise is is different. Here exactly is speckled noise in ultrasound images. Okay, so if you are going to make a project or any research about the medical images, so one of the basic problem is noise. So you can learn about the noise that if you are learning about the CT scan images, so cities you can understand that there are poison noise. So how you can remove that noise? So you can make an algorithm, you can learn the algorithm, you can and develop your own algorithm accordingly. Okay, so noise is one of the problem. Similarly, we have many other problems. We can have artifacts problem. Artifacts means like after image city image reconstruction, what happened exactly? Artifacts. Yani it means that some different kind of arts may generated. Okay, like if we can say straight line. Okay, so straight line, if that straight line is going to be slightly zigzag line. Okay, so that kind of things are called as the artifacts. Okay, so if such kind of things in the medical images, so we can say there are artifacts. So we can remove the artifacts. We have to develop such kind of algorithms. Okay, blurring is one of the problem. If one of the medical image is going to be blurred, some portion is going to be blurry. So definitely doctors are not able to predict something. So these are the things, and for that we have to develop some projects, okay, and research. Now, especially if we are talking about the medical images, so what will be the motivation exactly to work over the medical images? What type of objective you can choose exactly? So I am focusing, there are many other problems like textures, contrast. If contrast is poor, you can improve the contrast, the things. But especially if we are talking about the medical images, so medical images have big challenge exactly. Like first of all, I want to discuss that motivation. If you means that if you are going to develop some kind of project or research, there should be one of the most important thing that why we are doing this thing, why we are choosing medical image analysis classification. Why? Because we know the importance. It is exactly directly applicable to the society. Everyone and every person, one time, at least one time in a life, they have to uh, go with some medical things. Okay, so we know the importance. So I'm focusing here about the CT scan images. So one thing is that, as I previously discussed in my previous slide, that due to high radiation dose in computed tomography, due to high radiation dose, if the radiation dose is high, it means radiation dose means X-ray amount. If X-ray amount radiation dose is going to be high in computer tomography machine, there is a chances to develop the cancer cells. Okay, so that is one dangerous thing in CT scan machines. Okay, if high radiation dose is given, then cancer cells may generate it. So that is definitely, so that's why in CT scan machines, there are certain guidelines, and they have to follow that guidelines that this X-ray dose should be lie in between this range. Okay, but what happened? Why we have to give the high radiation dose? Now, the impact of radiation dose, high radiation dose or radiation dose is directly related to the CT image quality, which means if we are increasing the radiation dose, definitely it will improve the quality of the images. Now you can easily understand that if we have a machine, we have to increase the radiation dose, and definitely the quality of CT scan images are highly good, highly appreciated. But as we already said, that when we are going to increase the radiation dose, so inside the human body, what happens? Electromagnetic radiations are going to generate at a high radiation dose. High electromagnetic radiation is going to be increased. High radiation is going to be increased. Definitely the cancer cells are going to be more generated. And definitely it is harmful for the patients. Now you can understand the things about why I am discussing this topic and why I am going to stress all these things, because uh, in CT scan images, we cannot give high radiation dose. And if we are giving, definitely the chances of cancer cells may increase. Okay. Similarly, the risk to children due to radiation exposure is 2 to 3 times greater than the risk to the adults. This is the basic thing that from children's, pregnant ladies, okay, they have exactly more radiation exposure in normal times. So we generally doctors avoid the things, this is CT scan things for the children's as well as pregnant ladies. So what happen if we are going to decrease the radiation dose? So low dose CT images, which means the radiation dose is, if we are giving low radiation dose, the quality of CT scan images may degrade. So if the quality of images may degrade, what happen exactly? The quality may degrade. So the effect of noise, like I said in previous slide, noise is one of the problems. So that noise may generated into the medical images. Similarly, we have many other kind of problems may also occur, like artifacts, texture, blurring, all kind of things may affect it. But most important thing is noise. If we are giving low radiation dose, the noisy images may generate it. So as an objective, as a challenge, what we can do as for the society purpose, definitely that it is, this problem comes to the directly to the society. So what we can do, we can develop such kind of algorithms, such kind of softwares, so that we have low dose CT images. Okay. And over that low dose CT images, what we have to definitely, there are certain problems like noise can be a problem, and blurring can be a problem, artifacts can be a problem. So that kind of problem we can remove, we can improve the low dose CT images, so that the noise can be removed, blurring can be removed, as well as artifacts can be removed. So these are the things we have to include in our research, in our projects, so that we can develop such kind of filters, such kind of software, so that low dose CT images can be further improved. Okay. Now, there are many solutions. So in first one, there as I discussed here, there are many solutions. So these are some few solutions which are actually one of all are my publications where I work on. So one of the work is total variation. Okay. Another work is wavelet based thresholding. You can also use circular shifting based wavelet based thresholding, different patch sizes based wavelet thresholding, extended version of wavelet based thresholding. Or okay, now above one, all are the methods to remove the noise exactly with the help of non deep learning methods, or we can say traditional methods. But the last one, we can say it is with the help of deep learning methods. So I categorized here that you can solve the problem with the help of, now the concepts of image processing comes here. As a computer science person, we have to understand some basic concepts of the image processing. So in image processing, exactly two broad categories are there. One is non-traditional methods, or we can say deep learning methods. Okay, and the other one is traditional methods. Okay, without which we can say non-deep learning methods. So we will discuss about these things in our next slides. So these are the few methods. So with the help of these methods, or more than, we have a number of methods also. So, or with the help of these methods, we can improve the low dose. We can improve the quality of CT scan images, which are basically noisy, or we can say the contrast. We can also improve. So many things we can do. Lastly, how we can measure that when we apply some algorithms, like all these are algorithms, so how we can analyze the things, because we have we got the output images, so what things we have to measure. So important factors are basically for denoised images. So we have to check the things. Flat regions should be flat. In output images, we have to visualize the things and analyze the things, that flat regions should be flat. Image boundaries should be preserved, which means there should not be blurring. Texture details should not be lost. Global contrast should be preserved. No new artifact should be generated. So these are the major parameters. Through that, you can analyze the things. Like some students are going to write some research papers or projects. So with all these parameters, visually, you can discuss the things, that if some person is going to write a research paper or publication. So these are the main parameters, that smoothness, what is the major smoothness in the output images. Boundaries, which means sharpness is there or not. Texture details is available or not. Global contrast should be preserved. So these are the parameters which we can visually analyze. Okay. Now, this I discussed one problem about the CT image denoising. Okay, I'm not going to discuss in detail methods, but I am discussing here one more problem and one more solution. Okay, now we have one more thing, one more application exactly. Okay, now one more application is what? One application I discussed about the CT image denoising, and another problem we can discuss in terms of medical images, that is multi-modality medical image fusion. Multi-modality medical image fusion. Now, what happened in this exactly? Actually, multi-modality, first you have to understand about the multi-modality. Multi-modality means that images which are generated with the help of different sensors, exactly. Okay, different mechanisms. So let's suppose one image, okay, I'm taking example of medical images. Let's suppose one image is taken by MRI. Let's suppose brain, the images of brain are taken by MRI. The same images, that same like brain images are also generated with the help of CT scan machine, which means CT scan. So we have CT scan images of the brain. Okay, and the same area is also taken as from the CT scan images. So we have two different images, CT scan images, MRI images of brain. Okay, now the mechanism of CT scan images is totally different, and MRI images reconstruction, the mechanism is totally different from the CT scan images. Okay, so these two different images we have, okay, but that both images have the information of the brain of the same area. Okay, so some information is more, as I already discussed, that in MRI, soft tissues information is highlighted. In CT scan images, hard tissues information is highlighted. So what happened exactly? Generally, in many cases, in many critical cases, what happened? Doctors may suggest exactly in many times that you have to do for CT, you have to go for CT scan, and but when doctor is not able to find exact things, so doctor sometimes also suggest that you also go for the MRI. Okay, in many cases, in some cases, it is it is done exactly. So what happened exactly? If the problem is very critical, so doctors are sometimes doctors are not able to find out the things from the CT scan images as well as MRI. Now what happened exactly? We doctors are what doing exactly that they have to take they have to look out CT scan images, they have to look out the MRI images, but the overall conclusion, doctors are not so confident that to diagnose that problems. For that solution, we have one application which is known as multi-modality medical image fusion. So what happened exactly? We are taking two different images of same area, like this in this figure. We have first image, we have second input image. This image, first one is the CT scan images, second one is MRI images. Okay, so these two different images can be fused, okay, with the help of some algorithms, some methods, and finally we can obtain is one output image, okay, which is known as fused image. Okay, so between these two input image and output image, there should be some mechanism. Okay, you can use deep learning methods, you can use non-deep learning methods. So with the help of these things, finally you can fuse the things. And definitely, as a what is the advantage of this application, that when we are going to the doctor, if doctor is not able to find out the to conclude the things from the input images, CT scan images, MRI images, the doctor have a third opinion. The doctor can take the information from the fused images, and the doctor may be confident that informed, or we can say infused image, the information, the information is more in compared to CT scan images as well as MRI. So fused images are basically more informative images. So these, with the help of this fused image, more informative image, doctor can, it will help exactly to doctor to predict the things. Okay, one of the example is also this fused image is this fused concept. This concept is also can be applicable for other applications like multi-focus images. Okay, like in this below example, you can see two different images. So in one image, the foreground is okay, but background is blurred. Background object is blurred like this one. Okay, but in the second image, you can see the background is okay, but foreground is blurred. But finally, when we are going to fuse these two different images, so we can see that the background as well as foreground object both are okay. So this is how it will help also in for the purpose of multimodality medical image fusion. Okay, so however, in this inside this mechanism, the concept is utilized of the deep learning. So in our next slide, I'm going to discuss this thing, how we can use deep learning things. Now, now I'm going to discuss about the processing. Now, first two things I covered. First thing, how CT scan images is reconstructed, which means how medical images are generated. Second thing, the applications, two applications I discussed, denoising as well as fusion. Okay, now few things you must know about the image processing, because we are going to solve the problem with the help of image processing things. So under this image processing things, basically there are three levels, three processes area exactly. First one is low level processing, second one is mid level processing, and third one is high level processing. So I'm just giving a brief idea about these things. Maybe you know about these things. Low level processing, what we have to do exactly, when we have, uh, we are going to process some image processing concepts. Okay. And you are going, let's suppose you are giving some input data in the form of image, and you are getting output in the form of image. Okay. Let's suppose we have noisy image, so that is the input image. We process some algorithm and we got the output, and then we got output in the form of the images. Okay, so that means we are doing low level processing. Okay, for example, image compression. If you are doing image compression, so you are giving input image and you are also getting the output image, so it means you are doing low level processing. If you are going to increase the contrast, if you are going to decrease the contrast, if you are going to increase the sharpening, if you are going to increase the smoothness, if you are going to denoising, okay, if you are going to go for the fusion. So in each and every case, when you are giving some input and you are getting output as an image, it means that kind of processing is known as low level processing. Mid level processing, exactly in mid level processing, we are giving we are giving data, input data in the form of the images, but if we got the output in the form of attributes, or we can say features, like edges, contours, identity of individual objects, okay, such kind of things if we get, so that time we are exactly doing mid-level processing. Okay, for example, image segmentation, image description, okay, classification of the objects also can be the part of the mid-level processing. But mid-level processing is very highly connected with the high-level processing. So there are 3 level exactly processings. So in high-level processing, what we have to do? So under this high-level processing, so high-level processing exactly is applicable when you have to apply mid-level processing. So to achieve high-level processing, what we have to do? We have to give data as an input image. Okay. After that, we have to apply mid-level processing. So when we apply mid-level processing, we got the features. Okay. And that features are exactly utilized in high-level processing. So under this high-level processing, exactly we have input data in the form of the features. Okay, and through that features we have to apply some algorithm, some mechanism, and finally the output will come in the form of the information. Okay, when output comes in the form of the information, we can say that we are doing high level processing. Exactly, it is known as computer vision. Okay, so under this computer vision, we have been one of the many examples, like face recognition is one of the example. Okay, so that is exactly giving the information, face recognition. Okay, so any kind of recognition, any kind of prediction kind of projects comes under this high level. Okay, so in my last for the last module, I'm going to discuss the things about the deep learning exactly. So under this deep learning, what happened exactly? We have to understand. We have to some basic knowledge should be you must know exactly, because under this machine learning, deep learning, there are so many things. So it comes from the AI exactly. From the AI, there are some subpart comes as a the subdomain comes in the form of the machine learning. After that machine learning, there is again subdomain comes in the form of the deep learning. So what happened exactly when, so first thing I want to discuss you that when we have to apply machine learning, when we have to apply deep learning, that you must know, because in today, every student or every researchers, most of the researchers are going to work on the machine learning and deep learning projects. But especially for the purpose of a student, I want to tell that you must know when we have to apply machine learning and when we have to go for the deep learning. So under the machine learning, if you have kind of tabular data, value data in data set in the form of values, okay, so that values you can manage with the help of machine learning. Okay, when you have data in the form of the images, you have not exact data. Okay, you have only images, image kind of data. Then you have to go for the deep learning things. Okay, because deep learning have the mechanism, exactly mechanism that they can take the information from the images, okay, in the form of the features, and further that can be processed according to the different applications. So under this, we have supervised learning, unsupervised learning, semi-supervised learning, reinforcement learning, and today we have many more learnings. Okay, so you know some basic things. So if we are talking about the supervised learning, the date, definitely supervised means the date we have to give the labels of the data. Let's suppose we have apple, so we have to declare that this is an apple. Okay, so this kind of things comes under the supervised learning. And unsupervised learning, there is no labels. Okay, data is not declared that is apple, that is banana. It is not apple. So we have to follow some different approaches. Semi-supervised learning, similarly, some data are labeled, some data may not be labeled. We have reinforcement learning. So reinforcement learning are basically kind of observations from the actions, and according to the actions, they are exactly rewarded. Some values are exactly given. So according to the actions, according to the observations, so this kind of exactly processing can be done under this reinforcement. So these are the things. Now I'm going to discuss one topic here, because most of the students are going to follow CNN under this deep learning. So this I'm going to discuss here in the form of the methodology that many students, even my student, are very frequently using CNN. But when I'm going to ask the internal processing of the CNN, so they don't know exactly what is the internal things. So they are just using inbuilt function of the CNN. But I suggest that try to develop the complete procedure of the CNN, okay, so that your learning may increase exactly. Okay, so what happened exactly? CNN is definitely, it is the part of the deep learning. One of the popular model of the deep learning is CNN. Okay, so there are exactly two things happen, that under this deep learning methods, we have to train the data set, okay, and then we can use some new data for test cases. Okay, we can test the things. So one of the example I am using here, that how we can apply CNN. So under this CNN, you can see in the figure, we have input data. Over this input data, when we are going to apply CNN, so there are some important layers are there. Convolutional layer, pooling layer. These are the two basic uh, layers which are basically applicable in CNN. Okay, we can modify the things, we can include so many layers, but that is the minimum requirement, that we have to include convolution layer and the pooling layer too. And what is the purpose of that? That we have to learn the features. So exactly, we have input image, that image is going to, we are going to train the things. So we have to extract the features, and with the help of that features, we can train the features, and accordingly we can use for the further process, like we can do classification, we can do many other things, but classification is one of the popular thing to predict the some information. Okay, so exactly what happened, one by one we can see. So first of all, you understand about the convolution layer. What happens under the convolution layer? So convolution layer, under this convolution layer, what happened? There are two things. First thing is input image. So what happened in convolution layer? Actually, convolution is a mathematical function. Okay, and that function is going to be applied to the with input image with the help of a filter. Okay, so let's suppose this is one of the filter, this 3x3 matrix, it is a filter. Okay, this is let's suppose this is an input image. Okay, so how this filter will work under this convolution layer? So what happened? I'm just showing the example. So for first value, so let's suppose the filter size is 3x3. So first of all, we have to select 3x3. Let's suppose this is the 3x3 block. Okay, so this 3x3 block, this 3x block is going to be perform a convolution operation. So how it will produce the value? So first value is going to multiply with the first value, then second value is going to multiply with the second value. Similarly, third position value is going to multiply with the third value. Similarly, this position is going to be multiplied with the also. So the values which are on same position is going to be multiplied, and all values is going to be added. Okay, according to the filter. So finally, in output matrix, we have to produce the output into the output matrix. Like suppose this process, this is the process, okay, and this is the output matrix. So the center pixel, you can see this is the center pixel. This is the 3x3 block, and this is the center pixel. So over this position, you have to put the output in output matrix. You can see this 4 comes as an output when we are going to apply this filter. Okay, so this is the center position. So we actually, when we are going to perform convolution operations, so first row, remember this thing, first row, first column, last row, last column, these values may blank. Okay, so we cannot include these things. Okay, so similarly, we can obtain these things. Okay, like these things. So this is the convolution operation. Okay, so we can change the filter, we can get the different output values. Okay, so when we have processed first block, so what happened, what we have to do exactly, we can choose the, after getting the output value, we can choose the second block. So from the second position, we can took the new block. Okay, like this. This is the second block. So again, we have to perform the convolution operation with the same filter. We got the different value. Let's suppose this is the third way, 3. We got 3. And this 3 comes because on the position of the center of the block. So similarly, we can get the output things. So many students don't know how convolution operations exactly done. So here I am showing you this thing with the help of GUI also. So this convolution operation is main important thing which students, especially students, must understand. Okay, so this overall process will done under the convolution operation. Now, in deep learning, why deep learning is important? In deep learning, exactly, we can apply not only one filter, we can apply n number of filters. So you can see we have these n number of filters. Okay, so when we apply over the output image, so we can get the output image. You can see here convolved image column. So these are the different filters, filtered output images. Okay, so with the help of all output images, we can extract the features. Okay, now these features further we can use for the purpose of training, because in images we have only one thing through that we can learn exactly, that is edges. Okay, so if we can get the edges, because with the help of one filter like edge detection methods, like box filter, like segmentation methods, we can get the different edges, but each and every, there is no one single filter which can give you all 100% features of the images. So we can choose n number of filters, n number of methods, so that n number of output images can give you n number of features of the input images. Okay. Now there is, under this convolution layer, there is one concept that is called strides. So as I said in my previous slide, that you have to choose second block, then third block. Okay, similarly, you have to choose next block. So when you are going to choose next block, so there is the concept of these strides. Strides said that that how much jump you want to take. Okay, so if you are taking jump of the one block, okay, let's suppose this is 4 by 4 block, okay, and I am choosing next block from this position. Okay, so I can choose position from here, as well as I can choose position from here also, or I can choose the position of here also. So if I choose the next one block like this from this position, so it means I am taking the value of stride equal to 1. It means I am taking the next block, just next block. So it means the stride value is 1. If I am giving the one jump, okay, so it means I am giving the value of stride equal to 2. Similarly, I can choose the stride value equal to 3. So it means accordingly, I can choose different number of blocks. Definitely, it will affect to the output images. Okay. So this is the concept of the stride. Padding is optional thing. If you required the that blocks, let's suppose the last block is not completed. Okay, and if you required that to complete that that block, so you can put 0 padding. Okay, you can put here as a 0 value. Okay, so that is called as a 0 padding. If it is required, you can apply the padding. If it is not required, it is not applicable. Okay, now under this convolution operation, so now you understand that under this convolution operation, we have to perform convolution. Okay, convolution operation exactly apply to the input image with the help of filters. Now, after applying filter over the output image, so over the output image, exactly what happened, we can get, this is the filtered image. Let's suppose this is the filtered image. Okay, in this filtered image, you can see there are some negative values. This is the negative value. This is the negative value. So with the help of these negative value, when we are going to process the things, we are fetching the features. So these negative values may affect the other features. So that's why, with the reason of that, there is a concept of non-linear non-linearity ReLU function. Exactly. Okay, so in what happened in ReLU function, it is exactly a mathematical function. So in mathematical function, it said that the max, you have to choose this formula, which means the minimum value should be 0. So what we have to do with the help of ReLU function, where we have negative values, we have to convert that value with the help of 0. That you can see here, all negative values are going to be converted into 0, so that negative values may not affect to the other features. Okay, when we are doing some processing, that negative value may affect the other features. Okay, now and after this convolutional layer, okay, we have another mandatory layer, that is called pooling layer. So pooling layer, what exactly why we are using pooling layers? Pooling layer exactly because images are very large. Okay, so images are very large. If we are getting the information features in large form, because we have to train our data set, and data set doesn't have 1 image or 10 image or 100 image. Data set can be a large. It can be for 10,000 images, it can be 50,000 images, it can be 1 lakh images, 10 lakh images. So all images are we have to train. So and the size of the image are definitely heavy. If we are talking normal resolution size of the image, that is 512 by 512. Okay, 1024 into 1024. That are the normal sizes of the resolution size of the images. So such kind of large resolutions images, large data set. So if we are going to train such kind of data set, definitely we have to wait for 2 days, 10 days, number of months also. Okay, so with the help of pooling layer, we have to reduce the size of the resolution of the features which are obtained through the convolution layer. So with the help of pooling layer, we can reduce the size of the resolution size of the features exactly. So now we don't have images. Now we have, after applying convolution layer, we have features. So with the help of pooling layer, we can reduce the size of the. So there are exactly some methods under this pooling layer. We have max pooling layer, average pooling layer, sum pooling layer. So what we have to do exactly for, and this is an example. So with the help of pooling layer, we have what we have to do. We have to select 2 by 2 block. Let's suppose this is 2 by 2 block. Okay. So in this 2 by 2 block, what we have to do, if we are choosing max pooling, so we have to choose only max value. So 6 here, it is a max value. So we can put in output as a 6. Similarly, we have to select 2 by 2 block. So in our next 2 by 2 block, we have this 8. So similarly, we can choose 8. So similarly, we can apply the things. So this is max pooling. Similarly, if we are choosing average operation instead of max, so we can say it is average pooling, or we can apply sum operation instead of max operation. So that time it is called as a sum pooling. So it is for different research purpose, we can choose the type, one type of pooling. Okay, most of the times max pooling is more successfully worked in many applications. Okay, lastly, as in our first CNN model, we can see that we have input image. Over this input image, we applied these things. So as we discussed here, convolution layer, under this convolution layer, we applied the convolution operation. We apply ReLU function. We apply, after that convolution operations, we performed pooling layer. Okay. So these are the basic things, and this process we can perform n number of times according to your algorithm. So convolution layer we can apply n number of times. Similarly, pooling layers you can apply n number of times. Lastly, for the purpose of classification, okay, you have to perform classification. Like classification you can do with the help of like neural network concept, ANN concept exactly. So under this ANN concept, what happened exactly? Whatever data you received lastly, okay, all data, because it is in the form of the matrix. So last data you have to put in the form of the 1D array. Okay, let's suppose first value that you have to put in x1 as a x1, second value x2, third value x3, fourth value x4. If you have next value, then x5, x6, similarly. So in the you have to just replace the values x1, x2, x3 with the help with the values whatever you last received in your after the pooling layer. Now you have, this is called fully connected layer. Under this fully connected layer, you have to apply some artificial neural network concepts or classification concepts. So that what you have to do under this neural network, there are n number of hidden layers. These blue dots are exactly representing hidden layers. So under these hidden layers, some neural network concepts you can apply. Okay, with the help of neural networks, finally you got last some values like y1, y2, y3, all the values, and accordingly for the purpose of classification, whatever you can choose, you can develop the algorithm. Let's suppose you choose the algorithm that if whatever we got the highest value. So you can say that thing is represented that, or you can predict the things according to the large value. Okay, let's suppose in this example, let's suppose you have this input image and you are exactly doing testing. You already trained the things. Now you are doing testing exactly. So with for that same testing also, you have to perform convolution layer, function, then pooling layer, and number of times you can apply the things. And finally, you have to apply fully connected layer where you are applying artificial neural network concepts. Finally, you got some values. Let's suppose you got the values 0.04, 0.05, 0.9, 0.01. And from these values, you have to check that whatever you are getting the highest value. Let's suppose here it is 0.9. So 0.9 is tree. So you can predict that the input image is the image of the tree. Okay, this is how this CNN architecture exactly works. Okay, in fast mode, I just going to show this thing with the help of example. Let's suppose we know that this is the image of X. We know this is the image of O, but how we can train these things? So with the help of machine or CNN model, this X we can say, according to the supervised learning, we can say this image is X. This second image, it is O. So with the help of CNN, what we have to do? We have to extract the features, which means we have to apply convolution layer, we have to apply pooling layer a number of times, and finally those features, whatever the features we receive, so those features we can say that is X, that is 2. Okay, now I'm just going to show example how it will work exactly. So you can see here, these are the filters. First one, you can see it is filter, it is filter, it is filter. As I said that you can apply filter n number of times or n number of filters. So same size of filter you can apply over the images. Like one operation I can show you. Let's suppose this is the filter and this is the input image. Okay, so first of all, what we have to do, same size of block we have to select. As you can see, same size of block is going to be select. Now the same position values are going to be multiplied. You can see one is going to multiply it by this one. Okay, similarly second position and output we can put here like this. Second position value is going to multiply it. Same position values are going to be multiplied. Okay, like this. And finally, all values, now the filter is average filter. Finally, all values we are going to divide by 9 because the total values are 9. So according to the average filter, we divide by 9, and whatever output we receive, we have to put in the center position of that block. This is the position of the center position of the block. So with the same position over the output matrix, we can do it. So this process we have to perform n number of times. Okay, so one filter, this is the filter. Okay, this is the input image. When we apply it, this filter to this image, we got this output. You can see the size is the size is slightly reduced. As I said that first row, first column, last row, last column is going to be blanked. So we are not including that. Okay, similarly, over the same image, we can apply second filter. We can apply third filter. For this example, image is same, but the filter is, we are going to apply it, and we got some different values like this. Okay, so in convolution in CNN exactly, we can train the images with the help of filters. Now all images are going to be like this. These are exactly called output images when we are going to perform the convolution operation. Okay, like these three different filters we applied, 3 different output images we can receive. Okay, now we can apply pooling layer. Okay, so pooling layer, you know, maximum value you have to select. So we can choose the maximum values one by one. Okay, like this. After pooling layer, we have three output images. So over the 3 output images, we can apply the pooling layer. Okay, still if we have negative values, so we can apply ReLU functions, or if it is not, then it is not applicable. Okay, so after pooling layers, So definitely, as I said, that if there are negative values, you can apply the ReLU function. So you can convert that into the non-negative values. Okay. So 3 different output images. We applied ReLU function, so we can do these things. So you can make your own algorithm according to the, let's suppose how many convolution layer you want to apply, how many pooling layers you want to apply, ReLU functions you want to apply. There are many other functions other than ReLU function. So sigmoid function is there, tangent function is there. Okay. So this is how now accordingly, because so many times you saw, if you are using directly inbuilt function CNN, you cannot change the things. Especially I want to tell the students that when you are going to make some projects with the help of CNN, so if you are using inbuilt function CNN, you cannot do the changes. It will better that apply in the complete process so that you can see the effect on the results. If you are going to increase the convolution layer, if you are decrease the convolution layer, if you are increasing the pooling layers, if you are decreasing the pooling layers, what will be the effect on the results? Okay, so such kind of things you can do. Okay, so for this example, let's suppose this is the input image. We applied convolution, ReLU functions, all these process. Finally, let's suppose we got this output. Okay, 3 different outputs we received. Now we are going to transfer this information to the fully connected layer. As I told that in fully connected layer, what we have to do, we have to convert that image, that matrix into the 1D layers, like we set one by one in the form of the 1D layer. Now accordingly, now I want here we can, as we start that from the X or O example, now we have to check that this test image is X or O. So let's suppose we already have a trained data set of X as well as O. So under this trained data set, we received exactly some values. So we have to put all the values like this. Okay. Now exactly how we have to predict the things. So here exactly, this is the input image which we have to test. This is the input image which we have to test. This is the already trained data set which is trained by the deep learning. Okay, this is the trained data set of O. Okay, now the input image which we exactly received from here. Okay, these values. So these values we are putting here as well as here. These two are same values. Okay, now we have to check this information is connected with X or O. So how we have to connect exactly? We have to check the weight values. We have to add all the values and check the maximum values. Let's suppose maximum values are exactly 1. So you can see here, this is 1, this is 1, this is 1, and this is 1, this is 1, like this. So these are the features 1, 2, 3, 4, 5. 5 times are 1. So maximum values are 1. Okay. Like this. So we have to check now this 1. So this is the value of 1 and this is the value of 0.9. So accordingly, in respect of 1, we have 0.9. Similarly, there is 1, there is 0.87. Here is 1, here is 0.96. Here is 1 and here is 0.44. Sorry, 0.89. Here is 1, here is 0.94. Okay, so all in values of 1s are going to be added, that is 5. Okay, and all values in respect of 1, all values are going to be added, that is 4.56. So you have to divide all values, you got the value 0.9. Similarly, for the O, okay, you have to check the 1, 2, 3, and 4. 4 times our 1s are there. Okay, and in respect of 1, their values are 0.65, 0.45, 0.63, sorry, 0.44 and 0.53. When you add all these values, here it is comes 4, here it comes 2.07, divide, and you got 0.51. You can see the largest value. Largest value is 0.91. So you can say that this input image, which we are going to test through the deep learning, so you can say the port value is 0.91, which is highest value. So you can say this input image is of X image. So this is how this classification exactly done through the deep learning. Okay, so this is the same thing which I already explained. So the value of X is 0.92, which is 0.51. So definitely we can conclude that the highest value is going to be connected. So this is about, this is from my side. I think you got my major points which I discussed. So please, if you have any query, you can ask the things.
Thank you so much, sir. We have some questions from our students. So yes. So the first question I got here is, what are the techniques used to remove noise in CT images?
Okay. So if we are talking about the CT scan images, okay.
Yes.
So as I already told that first of all, we have to learn the literature. Through the literature, you can understand that what type of noises are in medical images. So if we are talking about the CT scan images, so under the CT scan image, there is Gaussian noise as well as Poisson noise. There are two broad kind of noises are there. Okay, so that kind of, to remove that kind of noise, we have many n number of algorithms. So as I discussed in my slide also, some methods I also shown you, like total variation. That is one of the method which is applicable to reduce the noise. So total variation is just a mathematical function where we have to exactly, the concept comes to minimize the variance, exactly, minimize the variance in the mathematical formulation over the pixel values. And that total variation is going to be modified with a number of ways, like I chose directional weight method, one of the I proposed in my work. So this is one of the way. Similarly, we have another ways like thresholding method. So in noise, exactly, it is one important thing about the noise is that noise is exactly attacking on the high frequency components of the images. High frequency components means edges. Over the edges, noise are very attacking. So what we can do exactly, we can apply some transforms like wavelet transform, curvelet transform, shearlet transform. There are n number of transforms. So exactly those transforms are responsible to convert that image into the low frequencies and high frequencies. And we know that noise is more popular to attack over the high frequency components. So to reduce that thing, we have a concept of the thresholding. So thresholding, through the thresholding, what we can do, we have to choose a threshold value. Again, to choose a threshold value, we have to use some mathematical methods. Okay, and over the threshold value, if we can say that below threshold value are generally values are generally considered as a noise. So if we have a threshold value and below values, we have to convert below, 0, exactly the values which are below from the threshold value, we are going to consider as a noise, and that should be going to be converted into the 0. And rest of the values we can put the same, as well as we can modify it according to your algorithm. So this is how we can do the city image denoise.
So I got another question here in chat section, sir. Amitesh is asking about in multi-model infusion, how can destructive interferences be countered in case one occurs at the time of training of the fusion layer?
Okay, so under this fusion exactly, what you can do, again, the same thing. If you are going to fuse two different images, that can be the same modality, that can be different modality. Okay, again, what you have to do, like in this example. So first of all, you that fusion can be done without deep learning as well as deep learning through the deep learning. So if we are using without deep learning methods, okay. So first important thing, that fusion is only applicable when we have same object. Okay, it is applicable for the same object, because when we combine two same objects, then we can get more informative images. Okay, if we can going to fuse two different images which are non-similar, so that there is, I think there is no use of that fused image. So so that is the first thing, that similar images should be required for the fusion purpose. Now, second thing, if we are talking about the without deep learning methods, so what we have to do, there are basic three operations. To fuse two different images, we have three basic operations exactly. One most popular method is, okay, basic method is average function. Okay, so when you have to combine two images, so you can do average operation, or you can choose second option, max operation, or you can choose min operation. There are only these three operations, basic operations, which are applicable in fusion concept. Whether you are using deep learning concept, whether you are using non-deep learning methods, only these three methods are generally applicable. Now, if you are using non-deep learning methods, so like you can use wavelet transform method. So what you have to do, you have to apply wavelet transform, curvelet transform, shearlet transform, and number of transforms you can apply. So transform have a tendency that it converts image into the low frequencies and high frequency components. So first input image, second input image. So first input, the low frequency component of first frequency component should be fused with the low frequency component of second input image. Similarly, high frequency component of the first input image is going to be fused with the second high frequency component of the second input image. So similar information is going to be combined. That is the basic things. Okay, same approach we are going to follow into the deep learning also. First, you can see here in this example. Okay, first what you have to do, you have to perform convolution operation of the convolution layer. You're applying convolution layer. So the features of the first input image you can obtain through the convolution layer. Similarly, second input image, over the second input image, you can apply the convolution layer, so that you can get the features of the images. So now you have to choose the algorithm. Now what you want to combine at that moment when you are applying first time of convolution layer. So if you want at that time, you can fuse the things. Fuse means that you can choose max operation, you can choose min operation, you can choose average operation. Okay, you can choose the base. Why? Let's suppose, for example, first features of first image feature and second image feature. So on the basis of let's suppose some mathematical operations like entropy, you can calculate the entropy of the first feature of the image. You can calculate the entropy of the second feature of the image. Whose entropy is highest? Okay, entropy means average information, average amount of information. So definitely average amount of information should be high. So on the basis of this concept, you can decide that you have to apply average operation or max operation. Definitely average amount of information should be high. So for this case, you have to choose max operation. So apply max operation between two images, between two features of the images. Okay, so this thing you can apply over the first layer, first convolution layer, or after that second convolution layer, or after third convolution layer, or after fourth convolution layer. Finally, whenever you apply, you got the single output image in the form of the features when you are applying deep learning. So this is how we can do the things under this multimodality.
Another question we have is, sir, which software is suitable? I think related to medical image analysis and classification. Is there any software is available or not, and which one is more suitable?
Exactly, if you are going to develop the things. So one of the best tool for image processing, especially for image processing, that is MATLAB. If you are going to perform only image processing, I'm talking about the only image processing. Only image processing means when you are going to do low level processing. Okay, so best one for learning purpose, especially for learning purpose, because in Python or in OpenCV, what students are not going to learn the things because there are so many inbuilt functions. In MATLAB also inbuilt functions, but in Python or OpenCV, there are large number of inbuilt functions. For each and every, there is inbuilt function. So students are not going to create some code. They are just using inbuilt functions, so the learning is very less. So to learn the things, to learn the concepts, MATLAB is one of the best tool to learn for the image processing. But when you are going developing a large a project which have large data set, and you are going to apply some deep learning methods. So for large data set, I suggest you have to go for OpenCV. Okay, in OpenCV, there is definitely you can use the features, but for learning purpose, definitely you try to avoid inbuilt functions, especially. Okay, when you are going to make a large project, definitely that time you can use the inbuilt functions. But for small projects, definitely students should have to avoid inbuilt functions like CNN function. Simply CNN function with the name of CNN, you can use in 1 or 2 line code, 3 line code, you can make simple projects. Okay, but if you are writing this code completely with yourself, student, and the theoretical concept, practical concept is going to be more highlighted. So it is, I always request to my students that don't use inbuilt function, just implement the things.
Yes,
So
last question. Yes, sir. We have one last question. How are noises? Okay, we are getting so many questions here in chat section. So, so how are noises distinguished from the actual data at the time of denoising? Is it via some threshold or what?
Can you repeat, ma'am?
How are noises distinguished from the actual data?
Okay. Yes. I got it. Exactly what happened. And noise have a category. Noise have a nature exactly. There is noise can be additive, noise can be multiplicative. These are the two natures of the noise. So multiplicative noise means you have to understand about the image exactly, pixel values. So let's suppose we have an image and let's suppose one pixel value is 30. Okay, so if you have a additive noise means that some additional value is going to be added. Let's suppose original value, clean value, pixel value is 30. But some noise component is going to be added. Let's suppose +2. So 30 is the original pixel value, +2 means now the pixel value is 32, and that 32 is what? Noisy pixel value. Okay, now how we can decide that definitely this +2, because we have to reduce that +2. Okay, but we don't have, but we don't know that +2 is noise. So we have to find out the solutions. So solution said, the thresholding concept said exactly, because researchers are already done so many research in this topic. So they said that you have to choose a threshold value. So it's some standard methods they exactly find out, like Bayes thresholding. Some methods I can suggest, like Bayes thresholding, bivariate thresholding, Chevrolet thresholding. Okay, these are what, these are some threshold, these are some methods which are basically useful to generate the threshold value. So over this threshold value, and the concept of thresholding said, there are two things, threshold value and thresholding. So first of all, we have to obtain a threshold value. To obtain a threshold value, we said Bayes method, bivariate method, Charlotte method. So these are the methods through that we can obtain a threshold value. Thresholding method have two categories: soft thresholding, hard thresholding. So through the thresholding, we can remove them. So they said thresholding concept said as well as the concept of denoising said that the noise are generally attacking on the high frequency components. High frequency components means edges. So if we can obtain the edges, and over the edges we can remove the noise. Okay, so to remove the noise, we have a concept of the thresholding. To get the edges of the images, we have transforms like wavelet transform, shearlet transform. So these are the transforms which are basically convert the image into the low frequencies and high frequencies. We know noise are attacking on high frequencies, so we are taking the data of the high frequencies. Over that, we are going to apply threshold value concept like Bayes thresholding, bivariate thresholding. So these methods we are going to apply it. We got threshold value. Over the threshold value, now we have to apply the processing of the soft thresholding or hard thresholding. This said that below values are the noise of the below threshold values are the noise. So we have to convert that values in the form of 0, and above values are the information, but that information can be noisy information. So above information you can modify it according to different algorithms or mathematics. So the things which we can do denoising exactly with the help of thresholding.
Yes, sir. That's also. Thank you so much, sir. The session was very informative. Today, we got an opportunity to hear your thoughts, and this will certainly be going to encourage our students in their future project works or research works to develop their skills in areas such as machine learning, computer vision, and data analysis, etc. So, on behalf of my department, Amity School of Engineering and Technology, I extend a really hearty vote of thanks to our speaker, Dr. Manoj Divakar sir, who spared time for his busiest schedule to grace this event, but also for enlightening our students with your commendable talk on this particular topic. I thank our director, sir, Dr. Sasi Bhushan, sir, for always supporting and guiding us. I would also like to thank our program leader for his effort and dedication. I'd like to thank our Amity School of Engineering and Technology faculty members for their support to make this guest lecture successful. Finally, I would like to thank all the participants here for joining us today. Thank you one and all present here. Thank you so much, sir.
Thank you, ma'am. Thank you, sir.
Thank you, sir. Thank you so much, sir.
Thanks a lot. Thank you.
Can I close, ma'am?
Ji, sir. Thank you, sir.
Yes, sir. Thank you.
Okay, ma'am. Bye. Thank you.